The Interdisciplinary Center for Neural Computation of the Hebrew University is the home of a world-renowned group of scientists focusing on the central questions as to how the brain computes. ICNC was established in 1992 to provide an interface for interactive research in neurobiology, physics and applied physics, computer science and psychophysics, with the objective of increasing the understanding of how the brain works, with specific focus on computational aspects of the nervous system. ICNC has state-of-the-art facilities for studying and modeling the nervous system at its different levels, from single neuron computation to signal processing in small and large cortical networks, to the system and the behavioral level. This is backed up by critical mass of 26 faculty members that make ICNC an outstanding facility in European terms. The ICNC groups work tightly together, using experimental and theoretical approaches ranging from molecular techniques, in vitro, intracellular, using DIC video microscopy and imaging methods with voltage-dependent dyes, in vivo multi-unit recordings in behaving animals, and imaging techniques using fMRI. Theoretical approaches include cable and compartmental modeling, information and learning theory, statistical mechanics and techniques from signal processing theory. A number of research centers in Europe, USA and Japan are now following the model established by the ICNC, including the Institute for Neuroinformatics, Laboratories de Neurophysique, the Gatsby Computational Neuroscience Unit, each of whom have sent missions to ICNC. The ICNC faculty members are intensely involved in teaching the 60 Ph.D. students at the prestigious Ph.D. program for neural computation, and in supervising the Ph.D. theses of a total of 120 Ph.D. students. ICNC faculty co-founded, co-direct and teach at the yearly EC Advanced course in Computational Neuroscience. The ICNC is well experienced in hosting international postdocs, sabbatical fellows and short-term visitors. The flow of 32 visitors during the first 15 months of the EU grant under the fifth framework is a demonstration for the attractiveness of the ICNC facility to European users. Ph.D. program. The Ph.D. program in brain research, computation and information processing is supported by generous donation from Alice and Jack Ormott. The goal of the multidisciplinary doctoral program is to train students to address various aspects of computation and information processing in the brain. This rapidly growing field is at the forefront of the sciences and technology. The program provides students with theoretical and experimental expertise in neurobiology, physics, computer science, psychology. This grounding will enable students to address fundamental issues such as, what computational problems must the nervous system solve? Which computational methods does the nervous system use? How are computations carried out by the different components of the nervous system? What operating principles of neural networks may be found in artificial computing systems? The program is designed to allow students with various backgrounds to supplement the knowledge in areas they have not studied, broaden the knowledge in topics crucial to every researcher in the field of brain sciences, and, finally, to allow each student to continue to broaden his/her knowledge in specific areas of interest. The program is made up of 3 academic components: required courses, common to all students in the program; optional courses, courses that allow students to acquire expertise in the fields of research of their choice; prerequisite courses. The admissions committee will provide an individualized list of prerequisites for each student based upon his/her prior knowledge of the field. The academic program is designed to allow students to complete the required coursework and prerequisites in 4 semesters. Students who have completed the bachelor's degree in any field with an average of 85 or higher, or who have completed a master's degree in any field, are eligible to apply to the doctoral program. Admission is contingent on the approval of the program's admissions committee. Upon completion of 3 required courses, students will take a qualifying examination to determine their ability to continue in the doctoral program. Students must also conduct a Ph.D. thesis project in accordance with the guidelines of the Ph.D. Student Committee. Students who successfully complete the program are granted the degree of Doctor of Philosophy in Brain Sciences, Computation and Information Processing.